So, funny story about this video. I can't use my camera to make it because I'm using the SD card, the data logging shield. So I'm going to have to suffice to use the camera on my computer, which is much poorer quality, but hopefully it'll do the trick. What we have here is the data logging shield for the Arduino, and a big old spaghetti factory because I chose to use wires instead of pins, which might have been a mistake. But hopefully I can follow them and explain what I'm doing here well enough. So for the shield itself here, got a little SD card in there to store the data, and we have it connected to pins 13 through 10 on the Arduino, right along there. Also got it connected to analog pins 4 and 5. As you can see on the little map there. And it's connected to the 5-volt power supply via the breadboard because we've got other components connected to the 5-volt. And then it's also connected to ground, which is also on the breadboard, and the 3.3-volt supply. And then over here we've got the screen, which I put too many wires on because I wasn't thinking. These do nothing. But we've got all the rest of them connected here, and some of them go straight to the Arduino. I would bother to go through every one of them, but there's a lot. I think I can explain it pretty well otherwise. So you see these yellow and orange leads are connected to Arduino pins 2 and then 4 through 9. And then let's see what else we got in here. And one of these leads here is connected. So let's see, that's the third one over. Is connected through this wire to the dial, which is also grounded and connected to the 5-volt supply. And what that knob does is simply dim the screen letters, which is nice. And then we've got a temperature sensor here. So the temperature sensor is connected to analog pin, which analog pin is it? Yeah, analog pin 0. And then it's connected to ground and to the 5-volt supply. The light sensor connected over here to analog pin 1, and then the 5-volt supply as well. And as you can see on the screen, backwards, because I'm using my computer camera, everything seems to be working fine. We've got the temperature reading at about 75 degrees in here. Here we've got the code for the data logger, and it starts with including several library codes: Liquid Crystal, SD, Wire, and RTC LIB, which we downloaded. Got a lot of pins and connections here, so I'm going to try and explain each one the best I can. So the chip is connected to pin 10. Liquid Crystal is the library code, and it's going to use 7, 8, 9, 4, 2, and 6 for interface pins. Temperature pin will be analog 0, photoresistor is analog 1, and then the light sensor LED indication will be activated by pins 3 and 5. This part defines the real-time clock, so it's going to have the date and time recorded into the file that's written. And this marks the LED pins to inputs. This sets up the date and time that the sketch was compiled. This will print initializing SD card to make sure that the chip is being used as output, I believe. And this part makes sure that the chip is there, and it will print to the screen that it's not present if it's not. This part will save a file, call it that, whatever's in the quotation marks there, and open a new file if one doesn't already exist. It'll save the name, it'll save the title and the data that we're collecting. So this part is collecting the temperature and converting it into degrees using a mathematical expression. In this section we'll be reading the light from the analog pin, and then map the light level for a range that we want. So instead of 0 to 900, we're going to go 0 to 50 or 150 and constrain it to that. And this is constraining the temperature range to a different span and making sure it stays between that, and then writing the value for the light level and the temperature level to the screen. Now, this just prints the date and time. Where did I go? This will display, okay, on the LCD screen. This prints the temperature and the light using temperature and light level on the LCD screen, so our data screen. And this converts from a digital range to 0 to 5 volts. And I did not explain that all very well, but pretty sure I know what each part does, and I hope it makes sense.